We're going to talk about Algorand smart contracts and the two layers of Algorand smart contracts, which is the stateful and stateless smart contracts. A smart contract is a computer protocol intended to digitally facilitate, verify, or enforce negotiation of performance of a conduct. Smart contracts allow the performance of credible transactions without third parties. What this simply means is, with the use of smart contracts, smart contract is more like an agreement between two or more parties or individuals trying to perform or do something. If those contract agreements or conditions are met, only then will the smart contract be executed successfully. Algorand smart contracts can be written in either the stateless or stateful manner. To be stateful means that some amount of storage on the chain is used to store values. This storage can either be locally or globally. Local storage refers to storing values in an account balance record if that account participates in the contract, while global storage is data that is specifically stored on the blockchain for the contracts globally. Like stateless smart contracts, stateful smart contracts are written in PyTeal and can be deployed to the blockchain using either the Go command line tool or SDKs. Okay, PyTeal stands for Transaction Execution Approval Language. PyTeal is an assembly-like language that can be used to write smart contracts on the Algorand blockchain. Stateless smart contracts, the primary goal of stateless smart contracts is to approve or reject pending transactions. Stateful contracts do not approve pending transactions but provide logic that allows the state either locally or globally of the contract to be manipulated. That is a difference between a stateless and a stateful smart contract. Let me repeat myself again. Stateless smart contracts, the primary purpose of it is to either approve or reject pending transactions, while stateful smart contracts do not approve or reject pending transactions but provide logic that allows the state either locally or globally of the contract to be manipulated. So for this presentation, we are going to focus mainly on stateful smart contracts. Stateful smart contracts can create, update, and delete values in either global or local states. The number of values that can be written is limited based on how the contract was first created. State is represented with key value pairs. The key and value are limited to 64 bytes of storage for both local and global storage. These values are stored as byte slices. Right, so in a state we must have a key value pair, a key and a value for every state. So we're going to look at a quick comparison between the local storage and the global storage. So local storage values are stored in the account balance record, while the global storage for the current transactions can be modified by the smart contract code. So in the next step, we're going to take a look at how to actually write these code samples or contracts, smart contracts, to see how to store values in either the local state or a global state. So we're going to write a program, smart contract program, that can create, update, and delete values from either a local or a global state. So like we earlier said, we are going to create a code sample that will enable us to write code or smart contracts that can store, update, and delete values being stored on the Algorand blockchain either locally or globally. This is we're using one of the Algorand smart contract SDKs through the use of Python, which is PyTeal. This enables us to write our smart contracts with Python. So the first thing we're going to do is to import the SDK into our application or smart contract. So this is a short implementation of how to import our PyTeal program or PyTeal SDK into our program. Now let's go ahead and create a variable called program, and then for this demo we're going to first start with the global storage. So if you're familiar with web API, you should know put, get, and delete. These are all terminologies that are being used in web APIs, which is very similar to that of PyTeal. So before we do anything, just let you know, these are built-in functions from our PyTeal that we imported. So let's go ahead and hover over our global put and see what it means. We can see a short definition or description of what this means. Write to the global state of the current application. Remember earlier I mentioned the key value pairs, the storage of key and values. This is what we're going to do over here. The key to write into the global application state must be evaluated to bytes. The values to write in the global state can be evaluated to any type. So let's go ahead and start. Alright, so we're going to create key value per bytes. I'm going to call this my key and then an integer. I'll make this 50. I can then print out our program. Before then, remember, we're writing in PyTeal through the use of Python, which will then be converted into smart contracts, into Teal smart contract directly. So I'm going to use this compile Teal statement and then pass in program. Okay, having done this, we need to know the mode of our application. So I'm going to do this mode dot application. So let's go ahead and run this and see what our result would be. So our program is going to run on our Visual Studio Code terminal over here. So I'm building it for the first time, which is why it's going to take a little bit of time. Right, so our code is still trying to compile and then convert. Alright, so like I said, we're going to write it in Python through the use of PyTeal, which will then be converted into Teal directly. So if we were to write this in Teal directly, this is what we're going to write. The Pragma version 2 is a header. We have our bytes, and then our integer, and then the mode of application, which is app.globalput. We're trying to write into our smart contracts on the Algorand blockchain globally. So we can go further and implement something else. We can do, so this is to write into, remember I said we can write, update, and delete. So let's go ahead and run our get command. That's the app.globalGet. This will fetch my key. So you can see the second program we just run on our terminal for app.globalGet. We can do something similar for delete. Global del. Let's go ahead and run it on the terminal also. So we can see our global puts, global get, and then global delete. We wrote into the chain, we got what we wrote and then deleted. So this is just a simple explanation or code sample of how to go about writing, deleting, updating. Alright, so having done this, we can clear this out and then do the same thing, but this time around locally. So we still have the 4 options we had for global puts. This is for local. So we have local delete, local get x, and then local put. So let's take a look at this. I have an integer or byte. Alright, so you might be wondering why in local put we have 3 parameters, while in global, well, running it globally, we just had 2 key value pairs. We still have our key value pairs here, but then this int 0, this particular int 0 over here is an integer, represents the the sender of the transaction, the person sending the transaction, because when running it locally, like we earlier said, it is being stored on the account address or on the account of the sender. So this int 0 actually represents the account sender of whoever is trying to run this this application or program. So let's go ahead and clear what we have what we've had so far, and then run it again. Okay, so we have an error. Let's go ahead and debug. Alright, so I just took some time off to debug what the error was. Our PyTeal is actually case sensitive, and earlier on we had a small letter I for where our int is, where our integer is, and same thing for here. So I just made it capital, the first I. As you can see here is our IntelliSense is picking it up for us. So let's go ahead and run it, having done this. So our program has run successfully. We have for local puts. So let's go ahead and do the same thing for local get. Alright, let's hover over local get and see what we need. For local get, we just need an account and then a key. So this means we do not necessarily need all the 3 parameters to pass in. Alright, so I just removed the last parameter as we just needed an account, and remember this 0 represents the sender or the account or the owner of whoever sends this transaction. If you hover over it, we can see the 2 parameters, an account and a key. An account, an index into transaction.account that corresponds to the account to read from, must evaluate to unsigned int 64. This means our program is into int 64 but unsigned. That means it must not contain or hold any positive or negative symbols or signs attached to it. So if you have a negative 10, for example, our program is not running. We have an input error, int negative 10 is out of range, which is what the unsigned means. So we can go ahead and do the same thing for local delete. Hover over it and then our account and key, just the way it is right here. Let's go ahead and run it. So our program has successfully run without any errors or problem. So this is just a simple sample, application sample of how to create, read and update smart contracts on the Algorand blockchain using PyTeal. So that was something I intentionally skipped. So if we do this, we can see something over here, local get x. Alright, so let's import the method or the built-in function and hover over it to see what we're supposed to do or what the function is all about. So we have an account, we have an app, and we have a key. So the only difference so far what we've done is that the app represents the ID of the application being checked and must be evaluated to unsigned int 64. So this is all we need to get that done. Application ID, and let's close it up. So we can see our results over here. Everything ran successfully. So remember, the transaction ID stores two value pairs, a 0 and a 1, representing if our transaction or code executed successfully or not. So we can do the same thing, or we could do the same thing for global get x. Let's hover over it and see what we need. So we can just remove this because we are running it globally now, so we do not need a sender's address. Let's go ahead and run it. So we still got a successful run or build on our program. So that is basically it about writing smart contracts with the use of PyTeal. PyTeal is a Python SDK for Teal, is a Python SDK that is being used to write Teal. So you can write your program in Python, it will then be compiled and converted to Teal language. If we were to write in Teal directly, this is what we're supposed to write, or this is what we're going to write. So having done this, I think this is self-explanatory, nothing too complex about it. This is just a simple sample application on how to write into global and local states, how to create, read, update and delete. So that's it for now. Thank you for attending.